Welcome back, tech enthusiasts. When designing efficient and highly scalable REST APIs, engineers must consider several key factors. Performance, maintainability, and flexibility are at the top of that list. One critical element that often plays a big role in O3 is how we handle query parameters. In today's advanced session, we're diving deep into query parameters, a concept that regularly shows up in real-world backend development and interview scenarios at top-tier companies. Let's get into it.
So what exactly is a query parameter?
A query parameter is a key value pair that you append to the end of a URL, and it's incredibly powerful. These little pieces of data provide optional input to the server, allowing it to filter, sort, search, paginate, and even apply conditional logic to its response. Let's break it down with a real-world example.
Imagine this API call. Here's what's happening. Location is Paris filters the data to show only properties in Paris. Guests is ensures the results are suitable for two guests. Sort is price arranges the properties based on pricing.
These parameters don't just make our APIs more dynamic, and they make them scalable, modular, and smart. Whether you're working on e-commerce, travel, real estate, or any modern web application, mastering query parameters is non-negotiable. And here's the kicker. Understanding and articulating how query parameters drive API behavior can give you the edge in any technical interview, especially at top-tier FAANGs like Google, Amazon, Microsoft, and more.
Let's start with filtering in query parameters, a fundamental technique to tailor API responses dynamically based on user input. Advanced interview rounds expect you to not just filter on fixed criteria, but to support complex dynamic filter chains with clear precedence rules.
How to support dynamic filter chaining with precedence in query params? The answer lies in building a predicate pipeline, basically a chain of logical conditions passed from metadata in the query params, applied with proper grouping to respect ANDs, ORs, and precedence. Here is an example in Java using the criteria API, where you construct predicates conditionally based on the presence of query parameters like status and category. This allows flexible filtering without hard-coding specific logic. How to filter polymorphic associations via query params in a single endpoint. This is where a type discriminator pattern shines, by joining related tables conditionally at runtime based on the type specified in the query parameter. Here's an example that dynamically joins different tables based on the type discriminator and filters accordingly. Mastering these techniques proves you can build powerful, maintainable filtering mechanisms demanded by large-scale systems. In interviews, don't just mention that you support filtering, demonstrate it. Explain how you implement dynamic filter chaining with predicate pipelines and how you handle polymorphic associations using type discriminator patterns. This kind of structured, in-depth explanation shows you're not just familiar, you're system-level ready.
Next up is searching in query parameters, an essential feature for modern applications to deliver relevant results efficiently. Interviews often focus on your ability to support multiple search modes and optimize search performance across languages.
How to enable fuzzy, prefix, and exact match search in a single query param? The key is to pass mode flags embedded in the query and delegate to different search strategies, like trigram similarity for fuzzy matching, prefix trees for prefix searches, or exact hash lookups for precise matches. Here's an example using Java full text search, showing how you can switch between search modes dynamically. How to optimize full text search across multilingual fields in large datasets? This means leveraging language-specific analyzers that normalize tokens per language to ensure accurate and fast search. For example, understanding these concepts will elevate your ability to design search functionalities that perform well at scale and across languages. So when you're asked about search implementation in interviews, break it down by mode, fuzzy, prefix, and exact, and explain your approach with clear logic and performance trade-offs. For multilingual search, show you understand language-specific analyzers and indexing strategies. Answering this way demonstrates both depth and practical system design insight, exactly what interviewers look for in strong candidates.
Finally, let's talk about sorting in query parameters, an often underestimated but vital aspect of API design, especially when you need to support dynamic multi-level sorting and sorting on computed fields.
How to implement multi-level dynamic sorting based on variable query parameters. You parse a comma-separated list of fields and their directions from the query parameter, then apply stable chain comparators in your code or dynamically build order by clauses in your SQL queries. Here's an example. We're building a flexible sort feature that reads field names and directions from a query parameter. This lets the API handle custom sorting like name ascending, age descending, all dynamically. How to handle sorting on computed or derived fields in real-time queries. One best practice is to use database views or inline expressions combined with indexed materialized columns, which optimize performance and make sorting efficient. For example, master these patterns to deliver flexible and performance sorting capabilities your users will appreciate and your interviewers will admire. In interviews, when asked about sorting, explain how you support dynamic multi-level sorting and real-time computed field sorting with practical examples like dynamic order by and inline expressions. This level of depth not only demonstrates your hands-on knowledge, but also makes it clear you understand both performance and flexibility, exactly what interviewers are looking for.
Now, let's dive into pagination in query parameters, a critical feature for handling large datasets efficiently and ensuring smooth user experiences. Advanced interviews often test your understanding of cursor-based pagination and combining it with filtering and sorting in a single query.
How to implement cursor-based pagination with opaque cursors in Java JPA. The idea is to use the unique ID of the last fetched item as a cursor, then query for entities with IDs greater than that to get the next page. This approach is both efficient and scalable. Here is a Java example that fetches the next page by filtering on the last ID, ordering by it, and limiting the results. How to combine pagination with dynamic filtering and sorting in one query. You can build your criteria query dynamically by chaining predicates for filtering and specifying order conditions, then apply pagination via the set first result and set max results methods. Here's a concise example demonstrating this pattern in Java JPA. Mastering these techniques will help you handle complex data retrieval scenarios with ease and impress your interviewers with your practical know how. These are the kind of answers that stand out in advanced backend interviews. When you walk through cursor based pagination and dynamic query building like this, you're not just answering a question, you're showing the interviewer that you've actually tackled these challenges in real projects and know exactly what you're doing.
Next, let's explore conditional logic in query parameters, crucial for writing clean, maintainable, and efficient backend queries that adapt based on optional input parameters.
How to implement conditional filtering cleanly based on optional query parameters. The specification pattern is your friend here. It lets you chain predicates conditionally, only applying filters when the corresponding parameters exist, keeping your code elegant and scalable. Here's a Java snippet illustrating conditional filtering with the specification pattern. How to apply conditional joins in JPA Criteria API only when needed. Avoid unnecessary joins by dynamically creating them only if the filter parameter for the related entity is present. This keeps your queries efficient and your application performant. Take a look at this example showing how to create conditional joins based on parameter presence. With these strategies, you're well equipped to write sophisticated queries that adapt fluidly to user input, a must-have skill for any backend engineer tackling advanced interviews. In today's AI-driven and competitive job market, interviewers expect far more than surface-level or textbook answers. They're looking for candidates who demonstrate deep, real world understanding, engineers who don't just memorize concepts but apply them in practical scenarios. That's why, during interviews, especially when discussing topics like REST API design, you should proactively go deep. Don't wait for the interviewer to pull answers out of you. Instead, guide the conversation by naturally touching on key areas like endpoint structure, filtering, pagination, sorting, and even security implications. This shows confidence, clarity, and technical depth. Yes, some candidates hold back, fearing that saying more might invite tougher questions, but in reality, it's your willingness to explore and expand on your answers that leaves a lasting impression. Training and certifications aren't enough anymore. What sets top candidates apart is interview readiness, the ability to explain, defend, and dive deep with confidence. Let's now talk about a powerful REST concept that often shows up in real world systems: nested endpoints. Also known as sub resources, these represent hierarchical relationships between resources, and mastering them, it's essential for handling structured data in APIs like a pro. This means get all bookings for user 123. It's a classic parent child relationship, users as the parent and bookings as the child resource.
Now let's dive into two advanced level questions that interviewers love to throw at you and how you can silence the room with confident, real world answers.
How do you enforce authorization checks for nested endpoints like /users/ID/bookings? The key here is The authenticated user should only access their own data unless they have elevated privileges. Here's a concise way to handle this in code. This check ensures the user can only access their own bookings or must have admin rights to go further. How do you validate child resource ownership in a nested route before performing operations? The system must ensure that the child resource, in this case the booking, actually belongs to the parent resource, the user. Here's a quick implementation. This protects your system from accidental or malicious access to unrelated data. So, the next time you're asked about nested endpoints, don't stop at just explaining the path structure. Walk through the auth checks, ownership validation, and real-time code like this, and your interviewers won't just nod, they'll know you live and breathe API design. Let's take it one step deeper and talk about something that shows up in almost every real-world API, query parameters inside nested endpoints. So here's the question. Do query parameters work with nested endpoints? The answer is a big yes. Take this example. This is what's happening here. Users slash 123 slash bookings is your nested endpoint fetching all bookings for user 123. Then we add question mark status equals upcoming and sort equals date are query parameters that filter those bookings by status and sort them by date. This pattern is super common in real-world applications. Airbnb filters bookings by status like upcoming or cancelled. Slack filters messages by user or date. Pinterest filters pins inside boards by tag. Now let's walk into the interview room and answer some advanced level questions like a pro. How do you dynamically apply query parameters like status and sort on a nested endpoint, such as slash users slash ID slash bookings? You need to ensure that filters are applied only to that user's data, not across the whole system. Here's a clear and concise Java snippet. This way, you preserve the parent-child relationship and add dynamic filtering. How do you prevent query parameter injection or misuse on nested endpoints? Security always matters. You must validate and sanitize every query param, especially for sorting or filtering. Here's a bulletproof check. This prevents attackers from injecting arbitrary fields or trying to sort by unsafe columns. So next time you're in an interview and they ask about filtering nested resources, don't stop at yes, it's possible. Go deeper, explain the relationship, the filtering, the validation, and back it all with real code. That's how you speak like an engineer who builds real APIs, not just reads about them. This is exactly the level of depth and clarity you should bring into an interview. When asked about query parameters or nested endpoints, don't settle for shallow definitions. Instead, explain how query parameters act as flexible, dynamic tools to filter, sort, and paginate data. For example, you might say, imagine you're searching for properties in Paris for two guests sorted by price. That's a perfect use of query parameters. Then confidently guide the interviewer into nested endpoints. Say something like, let's say you're trying to fetch all bookings for a specific user. That's where a URL structure like a user's bookings endpoint really shows the parent-child relationship. But don't stop there. Go further. Show how to enforce access control, comparing user IDs or checking roles. Explain how to validate that the booking truly belongs to that user to avoid security issues. And most importantly, back it all with clean, real Java code that shows you're not just talking, you've done this in production. That's how you leave an interviewer speechless, not by rambling, but by hitting every point with clarity, logic, and hands on examples. That's the difference between being a candidate and being the obvious hire. And with that, you've just mastered the essentials of query parameters and nested endpoints. In the next video, we'll bring these concepts to life using real-world examples from companies like Airbnb, Pinterest, and Slack, showing you how top platforms structure, secure, and scale their APIs. Stay tuned, it's going to be powerful.